Hello everyone. In this video I will provide a detailed overview of Activity 3.4, the irony of the Rust problem. This activity is designed for Year 8 Science students and it is a part of the Chemical Science Unit, Particles and Elements, the building blocks of the things around us. In this video I will discuss how this activity should be taught and I will recognise the pedagogical approaches that underpin the teaching of this activity. Please scan the QR code so that you can access the lesson plan and refer to this throughout the video. This activity is designed using the science understanding and science inquiry skills strands of the Year 8 science curriculum. This activity has a strong link to the following content descriptors. In this activity, students will conduct an inquiry investigation to explore corrosion as a contemporary socio-scientific problem. The key learning goal of this activity is for students to develop an informative video that explains what causes corrosion and identifies the problematic effects of corrosion on society. This activity is designed for a 90-minute lesson, or it can be split across two 50-minute lessons. The only equipment students will require are laptops or other devices, and access to the internet, YouTube, and textbooks for their research. To begin the lesson, I would start with a brief class discussion to outline what corrosion is. I would then display a variety of images of corrosion, as you can see on the screen. I would then ask the students whether they could provide further examples of corrosion that they may have seen. After this discussion, I would pose the two inquiry questions to the students to spark their interest and curiosity. I would then provide the students with a description of the activity and outline the key steps and what is required of the students. I would then ask the students to scan the Activity 3.4 Task Description QR code. When you scan this code, it takes you to a document that provides further scaffolding of the task. This document provides students with ideas about what to research and how to structure their video. I would then ask the students to scan the Activity 3.4 Resources QR code. This code takes students to another document that contains a list of resources students can use as a starting point for their research. Approximately 60 minutes should be allowed for students to conduct their inquiry investigations. Each group will need to determine the research topics and then divide these amongst each member of the group. After they have completed their research, students will need to work collaboratively to construct their video. The QR code should be accessible on the slideshow so that students can refer to these resources when needed. To conclude the lesson, each group will present their video to the class. Students' ticket out the door is to show that they have written down one interesting fact from each presentation. I will now outline the four pedagogical approaches that underpin the design of this activity. An inquiry-based pedagogy was central to the development of this activity. Inquiry-based learning has become a widely accepted and adopted pedagogical practice. Hackling acknowledges that inquiry-based science education allows effective learning to occur, as students are encouraged to actively engage in the learning process and construct their own meaningful knowledge. Hackling also identifies that the most effective way to promote inquiry in science lessons is to incorporate investigations. Minna, Levy, and Century identify that inquiry-orientated investigations in science enhance the level of student engagement, develop scientific literacy and inquiry skills, and produce higher-order learning outcomes compared to traditional laboratory activities. I decided to use an inquiry investigation to encourage students to be involved in the learning process and allow them to develop meaningful knowledge about socio-scientific issues. When developing the unit overview, I used the 5Es model to structure the progression of inquiry over the course of each topic. The 5Es model was founded on a constructivist approach to learning. Constructivism describes learning as an active process of constructing meaning from knowledge, through assimilating new information into pre-existing knowledge or conceptions. The 5Es model consists of 5 interconnected phases of inquiry, as shown on the screen. This activity particularly focuses on the explain and elaborate phases of the model. The first inquiry question encourages students to explain what causes metals to corrode. The second inquiry question encourages students to elaborate on their knowledge and apply it in a contemporary context, as students are challenged to investigate why corrosion is a socio-scientific issue. To facilitate the integration of technology in this activity, I use the SAMR model. The SAMR model is a popular tool as it supports teachers in designing ICT learning experiences that facilitate meaningful and transformational learning. Patton emphasises that higher-order transformative learning occurs at the modification and redefinition levels. Patton recognises that using iMovie to create a video that explains and elaborates on a concept is an example of learning at the penultimate redefinition level. Therefore, this activity allows learning to occur at the redefinition level, as this task enables students to modify and redesign the information they access and present it in a personalised way. This activity has strong links to science, technology and society, as learning occurs in, through and about each of these realms. McLeod recognises that the STS approach is beneficial as it provides contextual learning experiences that develop students' science literacy and inquiry skills. Sadler also recognises that when socio-scientific issues are investigated, the learning is enhanced as the science is contextual and has contemporary relevance. Our activity encourages students to investigate the socio-scientific issue of corrosion. I believe that this activity is closely connected to science, technology and society. As students learn about the science behind corrosion, they use technology to demonstrate their knowledge and understandings, and they identify and investigate the impact and effects of corrosion on society. To evaluate the effectiveness of the activity, I would suggest that the teacher uses the presentations as formative assessment to determine whether the students are able to answer the questions on the screen. This activity can be determined successful if students are able to respond to these questions. Particularly, they should be able to explain the factors that cause corrosion to occur and explore the socio-economic problems caused by corrosion. Overall, I believe that this activity is an exciting and innovative way to teach corrosion to Year 8 chemical science students. I believe that this activity develops 21st century learners who are able to use science and technology to explore and critically evaluate contemporary socio-scientific issues. Thank you for taking the time to view this video. I hope that you found it helpful and are able to implement this activity in your classrooms.